My colleagues who helped me develop this presentation, Dr. Mary Beth Murray is Director of the Arctic Institute of North America, Richard Sparvey and Aurora Van Buren work with me at Stantec in Calgary. We all work in the intersection point between science and traditional knowledge. None of us are experts on microbes, but hopefully you'll see some linkages to at least some of the previous talks. Again, I'm past Vice President Indigenous with the University of the Arctic, Director of the Labrador Institute, originally from Labrador, which you can see right here. The top 1/3 would be considered an Arctic region, down to about here would be subarctic area, permafrost, discontinuous permafrost here, and some continuous permafrost north of that. I thought I'd just mention some of the global processes, which you'll hear a lot about this week, I'm sure, and we've heard about already this morning. There's evidence of Arctic atmospheric temperature increases. 2016 was one of the hottest on record, at least since the 1900s, the turn of the 20th century, sorry. We also see evidence of temperature increases. I believe in 2019, the globally surface sea average surface temperature of the seas were about 1.5 degrees Fahrenheit above the long-term historic mean. This image is from NASA showing the circumpolar world. The green areas would represent regions over the past 30 years where there's been a demonstrated length and growing season. This map shows the distribution of indigenous peoples in the circumpolar world. The Arctic Council estimates there's about 500,000 indigenous people in this region, about 4 million people in general. This map, we've seen something similar to this in one of the first talks, shows the global distribution of permafrost. We see this blue patch in Central Asia. If we include the people in that region, there's about 35 million people living in a permafrost zone globally. So what are northern people seeing with respect to climate change? This image was given to me by Dr. Mary Beth Murray. It shows a sinkhole in Alaska. This sinkhole was associated with permafrost thaw. So permafrost thaw is causing negative impacts on physical infrastructure in the north. We're seeing increasing evidence of wildfires, which you don't often think about in Arctic regions. The image on the left is from the tundra in Alaska in 2012. There's a wildfire occurring there. On the right, we have an image of a wildfire burning out of control in Greenland. 2019 was one of the heaviest wildfire years on record in Greenland, apparently. We're also seeing changes to animal distributions in the north. Wildlife populations are changing. I'm a wildlife biologist, by the way. Sorry, I forgot to mention that. The image on the left is from a newspaper clipping showing that Pacific salmon, which normally would be occurring down in this part of Canada, are now occurring in the Western Arctic. The image on the right is also from a newspaper clipping showing that cat parasites are now being found in Arctic beluga populations. This is some data I compiled personally for changes in animal distributions in Labrador using various sources, including traditional knowledge, as well as the scientific records. All those species shown in white would represent a northward range expansion. So fairly substantial from everything from small mammals like rock wolves to larger animals like coyotes and moose, but also a number of bird species here as well, which we just heard about and how they can introduce vectors to the north and possibly to the south, depending on their migratory movements. We're also seeing changes in ice patterns in the north, and people that live in the northern regions talk about this quite a lot, especially with respect to the timing of freeze and thaw in the fall and spring. This poses real large impacts to their travel routes, their ability to access country foods. There's safety risks. What once were thought to be safe regions to travel, for example, on ice, sea ice, might now be dangerous at certain times of the year. Same on land. There aren't many roads in the northern regions. As winter progresses, lands actually become more accessible because brooks and streams and rivers freeze up. But as we see, environmental changes can impact those kind of freeze-thaw patterns, which then limit people's accessibility to country foods. And also can negatively impact traditional land-based practices. which in turn can have negative impacts on cultural transmission because people aren't doing the same practices that they normally would do, which can impact community health. So we see a lot of issues in the north. They may not all be able to demonstrate scientifically a link, but we know there's a lot of issues around substance abuse, domestic violence, and suicide rates in some northern communities. And these things may all be tied together. Northern areas, the environmental change is also causing impacts on country food harvest. So northern areas obviously lack a lot of significant agricultural ability to produce agricultural crops. So northern peoples rely on country foods to support their diets. Fish, caribou, seals, very good sources of nutrients. Here we see Arctic char to dry in Nunavut. And coupled with this, we see a lot of issues around food security in the north. In particular, we see that store-bought foods are very poor quality. So a lot of times you go into stores in the north, there's moldy vegetables and fruit, limited food choices, and very high prices. So these are health issues that you're all going to experience when you do work in the north, but when you go up to do your research, you're going to be, people have these problems on a daily basis that you'll have to deal with as well. So this image here is from a store shelf in Nunavut, and these are packages of juice. And we see here, this is a 1 liter package of orange juice, and it's going for over $7 Canadian. This is a 2 liter package of apple juice, is going for over almost $14 Canadian. So very high food prices. So those are some of the issues that people in the north are dealing with. Now I want to change gears a bit and talk a bit about the interface between traditional knowledge and science, which is an area where I work. And for each of you who want to do work in the north, many of you are well-trained scientists, but you may be less familiar with traditional knowledge and how it might benefit your programs. But for those people who do work in this area, you would probably be familiar that these two knowledge systems are often portrayed in conflict. And when people discuss them, they talk about how they differ. And those differences are true. But in this section here, I just want to talk about some of the similarities between these two knowledge systems, just to make it a bit more comfortable in the event that any one of you want to incorporate traditional knowledge into your programs a bit more. So a few years ago, I was asked to co-chair sessions of the Indigenous Peoples Secretariat, and we produced a set of traditional knowledge principles that were submitted to Arctic Council and adopted. The Indigenous Peoples Secretariat represents the circumpolar indigenous peoples in Russia, Canada, US, and Europe, excuse me. This is the definition that they used in those principles. And basically for them, they describe traditional knowledge as a systemic way of thinking about phenomenon, a body of knowledge generated through cultural practice and lived experience that's developed over time and is still a developing living process. And one of the first shared characteristics I just simply wanted to mention, and we would all recognize this, of course, is that they're both knowledge systems that help people understand nature. This image here is of on a bison skin from Alberta, showing a historic record of a bison hunt in that part of the world. So indigenous peoples did have record keeping in different circumstances. Both knowledge systems share a characteristic in that there's a lot of variety in how they're both expressed. So we would probably recognize that how a wildlife biologist like me does science differs from how a particle physicist would do it. How a psychologist practices science differs from how a geologist would do it. And so that kind of demonstrates the variety that exists within the scientific field. That variation also exists within traditional knowledge systems. There's about 370 million indigenous people worldwide, representing about 5,000 different groups in 90 countries. And how they all practice their traditional knowledge varies in terms of scope, focus, and practice. But the important message here is that both knowledge systems have a lot of variety in how they're expressed. Both knowledge systems also accumulate over time. You'll often hear this with respect to traditional knowledge. Again, this is from the traditional knowledge definition I just gave, how it develops over millennium. But some of you would obviously be familiar with the quote below from Isaac Newton, you know, if I have seen further, it's by standing on the shoulders of giants. Well, that quote is from 400 years ago. And at that time, he was acknowledging that people came before him. And in fact, for those people who are interested in the history of science, you would probably recognize that it goes back to the Greeks and the people from the Middle East and Asia as well. Both systems are imperfect but reliable, and in the next slide I'll explain that. But both systems are based on people. Neither system is perfect. They're both fallible, but they can produce reliable information. Traditional knowledge has enabled people to survive in harsh environments for thousands of years. You can generate repeatable predictions. If you're not able to guess where animals will occur, you're probably going to starve. And so that helps decision making, and it has supported northern indigenous people survive harsh environments for a long time. Both systems are self-correcting in that they're adaptable. We would be familiar that science has paradigm shifts and model replacement. Likewise, indigenous knowledge, people are able to adapt that knowledge as the environment changes. Knowledge transfer is another important piece of traditional knowledge. Teaching and learning is foundational to both. Communication is a key element, including oral communication. So you'll hear people discuss traditional knowledge, and they'll often say that's very much an oral-based knowledge system. Well, science also has a large oral component. We have conferences, we have lecture halls, and so on. Both systems have expert practitioners, and this expertise is supported by third-party endorsement within the scientific fields. The universities provide this endorsement and granting of degrees. Peer reviewers review your articles before they're published. But likewise, traditional knowledge systems, traditional knowledge holders, experts, they receive peer review as well from their community members. If you go into a community, they will acknowledge who their experts are on a given topic. This is my grandfather right here. He knew more about wildlife biology than I ever will. So, but again, it's just a demonstration that that people who make a living off the harvesting products in the land have a deep insight into environmental processes. So now I wanted to move on to some examples of, of indigenous knowledge of the microbial world. These examples come from Labrador. None qualify as a threat, unfortunately. Otherwise, there would be a great linkage to this conference. The first one I wanted to talk to you about was sealskin cleaning. So the Inuit in southern Labrador will place sealskins in bogs in the spring, and what happens is the microbes in the bog will remove the hair from the pelts. And I've often wondered whether this technique could be used in other leather industries. It's very green in terms of how it's done, but there's also questions about how changing temperatures will impact bog function generally, including for things like this. Another example from indigenous knowledge deals with the harvest of red berries. Elders won't allow the harvest of this particular fruit before the first frost, and there's a couple of reasons for that. One of it has to deal with the ripening of the fruit. The other issue deals with a fruit worm that exists in the berry, and I spent quite a lot of time looking for this fruit worm, and it's not easily observable by the naked eye, so I've often wondered how the elders knew about this worm. But if you look at the research, people in agricultural science recognize that that worm is a larva of this particular moth. Excuse me. And the last one I wanted to discuss is an example of a microbial world, seal finger. This is an infection that occurs when people deal with seal pelts. It leads to inflammation when seal product enters the open wound, leads to an unusable finger. Sometimes it'll lead to amputation traditionally. The region of Canada where I'm from, they would use a traditional treatment would include a poultice based of a larch tree. But I'm curious what warming waters will mean for the prevalence of this particular infection. Apparently it is caused by a bacteria, possibly a mycoplasma, but it's not quite clear. There's not a lot of research on the causes of seal finger. Maybe some people in the audience will know. And I just want to close with talking about working with Indigenous partners in your work. Many of you are physical scientists or medical scientists, and you may not have strong connections in the north. But if you're able to partner with northern peoples, you can reduce your program costs, develop capacity for long-term monitoring, leave a legacy of training and education, and possibly gain some unique insights into ecosystem processes, possibly even on some emerging microbial threats. And that pretty much ends my presentation. I rushed it a bit to try to get back on schedule, so thank you very much.